2 is on histograms. And a histogram is a graph consisting of bars of equal width drawn adjacent to each other, unless there are gaps. And those bars, again, unless there are gaps, are touching. So something like this graph that I am drawing. Something like that. The horizontal scale represents the classes of data, and the vertical scale the frequencies. The heights of the bars correspond to the frequency values. And when it comes to these histograms, they visually display the shape of the distribution of the data. It shows the center, for the most part, shows the spread of the data, identifies any outliers, essentially the graph of the frequency distribution, for the most part. For the horizontal scale, the cross boundaries, cross midpoints, or cross limits can be exchanged with those crosses. Likewise, we can graph relative frequency histograms, which displays the relative frequencies on the vertical scale. And this top one here is the frequency histogram. This bottom one's the relative frequency histogram as a percentage. And both of them, notice how they kind of have that normal distribution based shape, right? I mean, mind you, it's definitely off. We do have one of these bars that are the highest to indicate whether the center should be somewhere along here, but it looks very close to being a normal distribution, or at least approximately normal, to use a specific terminology. The goal, though, of these histograms is to understand characteristics of the data. So center, variation, shape, presence of outliers, and how it changes with time. So, from that idea, the basic shapes that we could have are a normal distribution. It's a bell shape, as many data collections are approximately normal, like that one that we just saw a few moments ago. We could superimpose a normal distribution over it to see it's approximately normal. Again, it has some variation with some of these bars being outside of the normal distribution, but that's why it's approximately normal. A perfect normal distribution is like this green graph right here, or at least more perfect. I mean, again, it's not 100% perfect, but this is a approximately bell-shaped or normal distribution. The uniform distribution, this is where the possible values all occur with almost the same frequency. I say almost because not all these bars are the same height, but most of them are, which is why they're pretty much uniform and why this is a uniform distribution. A right or positive skewed histogram, this is where it has a longer right-hand tail and has most of the data to the left. Kind of just like the toes on your right foot. Likewise, for a left negatively skewed, a longer left tail, and all the data is here on the right, and that would be like the toes on your left foot. So to give an example, we could graph the IQ scores for the low lead level group, and you could see we have a relative frequency, the frequency and relative frequency histograms graphed over here. And again, both of them have that shape of being approximately normal. Approximately normal. But, of course, just looking at a histogram to judge if it's normally distributed or not, it's not necessarily the most scientific way. Mind you, we do have calculations that could give us a better estimate if it is. But for the time being, we could assess normality through a normal quantile plot. This is where the normal distribution itself has a definition of inside of this normal quantile plot, the normal distribution. This is where the pattern of the points in the normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. So a distribution is not normal when the points do not lie reasonably close to a straight line pattern, and the points show some systematic pattern that is not a straight line pattern. So for example, we want to know, are these quantile plots normally distributed? This one's a yes. Mind you, we do have some points outside of this overall trend inside of a line. But notice how all those points, they are pretty close to where this line here is. And they do increase just like the straight line would. So since there's no other pattern, and it does increase in the same fashion, this is normally distributed. This one, mind you, has a bit of a pattern here. It starts off small, but then increases here to the right. And so because of that, that is definitely not a straight line pattern, and as you can see, a lot of data points are outside of this line. So no, it's not normally distributed. This one is closer to being near that line, but notice something. This kind of has an S shape, a faint S shape, but because of it having that S shape, we can't say this is normal. So this is not a normal pattern. It's a very highly susceptible one. Thank you.